Hello everyone, welcome back to Leap, where you learn once and remember forever. For those who are watching Leap videos for the first time, I am Deepika, a mathematics educator based in Melbourne, who tries to make math AEAP as easy as possible. Let's get into the video. In this video, we are going to see how to prove a typical type of trigonometric identity, which involves the trigonometric ratios in fractional form within square roots. Let's see how to prove this problem. The given question is to prove the square root of 1 minus sine theta divided by 1 plus sine theta equals secant theta minus tan theta. When you are given such a question, the first thing that should come to your mind is the conjugate method. Let's see how it works. To begin with, we rewrite the left-hand side of the given identity. So the left-hand side of the given identity is 1 minus sine theta divided by 1 plus sine theta within a square root. So when I say conjugate, what it means is that you look at the denominator, right? So you see that it is in the form of a plus b. So when it is in the form of a plus b, that means the conjugate is going to be a minus b. If the denominator is of the form a minus b, then the conjugate is going to be a plus b. So here it is 1 plus sine theta. So the conjugate of the denominator is going to be 1 minus sine theta. So how do we do that? We multiply that conjugate with the numerator and the denominator of the given fraction. So taking the square root again and rewriting the fraction. Now we multiply the numerator and the denominator with the conjugate of the denominator, which is 1 minus sine theta and 1 minus sine theta. Now it's always good to put them in brackets, so it is easier to identify which identity fits in better. Now as you observe the numerators, you can see that it is 1 minus sine theta times 1 minus sine theta. So we know that if you have a plus b times a plus b, it is going to give you a plus b the whole square, because x times x is x squared, right? So we get 1 minus sine theta the whole square. Now as you look at the denominators, you can see it is 1 plus sine theta times 1 minus sine theta. This looks pretty much like the identity a plus b times a minus b, which is equivalent to a squared minus b squared. So your a is 1 and b is sine theta. So we replace that and we get 1 squared minus sine squared. Now proceeding further, we get 1 minus sine theta the whole squared divided by 1 squared is 1 by itself and sine squared theta. We also know that there is a trigonometric identity which says sine squared theta plus cos squared theta equals 1. So when you transpose sine squared theta to the other side, you get cos squared theta equals 1 minus sine squared theta. So we have 1 minus sine squared theta here, which is equivalent to cos squared theta. So you can replace 1 minus sine squared theta by cos squared theta. We get 1 minus sine theta the whole squared divided by cos squared theta. You can see that the numerator is a perfect square and the denominator is also a perfect square. So as you take the square root for both, you get 1 minus sine theta divided by cos theta. This cos theta is a common denominator for 1 and sine theta. So we can rewrite this as 1 over cos theta minus sine theta over cos theta. We also know the reciprocal relations. 1 over cos theta is the reciprocal of secant theta and Sine theta over cos theta is tan theta. So that is basically your right hand side of the equation.
That's it. We are done. So this is how you prove using conjugate method. Thank you so much for watching. I hope you were able to understand the conjugate method of proving identities in a much simpler way. If you like this video, please give a thumbs up. And don't forget to follow Leap to learn more and make math AE AP as easy as possible. Thank you.